Hi everyone, it's your TA again, and today we'll be discussing about data wrangling week 5, day C11. So we'll be basically diving into data wrangling with Python, focusing on using pandas and NumPy to clean and pre-process data, like noisy data sets, preparing data for analysis. This video is going to guide you through essential techniques and some code examples. So firstly, what is data wrangling? So normally, we have to clean our data, we have to pre-process our data to make it ready for a model which you guys will be building after midterms. So for that, the data has to be like fit for the model. It couldn't have any raw values because then it'll be occupying model spaces. So that's why we have to clean the data, and that's what we're going to do in this section. So a lot of the text here that's just saying that data wrangling is the way to remove errors and combining data sets to make them, to analyze them and make them basically fit for the model. It's very important because if it's not, then we're gonna have a lot of wasting spaces. We're gonna have a lot of outliers that's gonna make our model not work like we want. And machine learning model input, almost all the traditional machine are using numbers. Yeah, all the machine learning models, even ChatGPTs and other, use vector data to store our tokens. So everything is in numbers, so even one slight mistake will be affecting everything. All right, so what is data quality? So data quality is basically the accuracy or the reliability of our data, and it is very essential to have a high quality data for meaningful analysis. That's what he is talking about in these few sections. If you can see in these sections, there are a lot of noise in the data. The data is very static, which we don't kind of prefer. Two sine waves is just simple like this, but if you add noise on it, it's going to be distorted or some sort of data. But sometimes noise is good as well. If you want to do dip, it's very good. It's kind of like physics waves papers. They will talk about why noise is important sometimes. All right, outliers. Okay, let's go to our code. So we're going to go with the same file that we had before. And how do we find out outliers? So let's say we have this thing. All right, df.describe. I have this thing over here. I want to find out the 25 percentile, the 50 percentile, and the 75 percentile. So that's what I got to find out first. This is the first quartile, this is the median, and this is the third quartile. So what is the formula to find out the outliers? First, you need to find out the IQR. That is the interquartile range. That is the Q3 minus of Q1. So that is the formula to find out your IQR. Now, what are outliers then? All right, let's say outliers are any numbers that is above our Q3 plus IQR, or any number that is below Q1 minus IQR. So that's going to be our outliers. So there I said that's completely outside. See, these points kind of don't fall within that. Those are the outliers. In our data set, if we didn't have this section and in this section, then if we only had the middle one, it does make a lot of sense. Now, can outliers just be a thing that is like the data is wrong? It's almost not the case. Let's say even if we take the age of the people that are studying in this class, let's say the majority of you are 18 to 20 years old, but there are a few people who are like more than 30. So those people are outliers, right? But they doesn't necessarily mean that they do not belong to that data set. They might belong to it, but it does just not make sense because they are not like the others. All right, see, there's more examples of outliers. Removing outliers. So Python data frame equals to data frame filter expression. Okay, yeah, we could try it. I think, let me pull up a better data set in this folder. So our folder is in projects, and I think I do have a section called regression analysis papers. So just train.csv. Okay, I'll be moving that to our folder. Just give me 1 second. Projects, Just give me a few moments here. I'm trying to navigate to my system. Oh yeah, and if you haven't installed the Jupyter Notebook, please do so. It's very good for data science. You'll be doing it in your future classes, so why not put your hands in it, right? Okay, so relation analysis paper taste.csv. I'm gonna put it in our folder that is I'm doing it in the TSC101 videos. So I did put it over here. Alright, if I reload it, it should come. Yeah, it did. Alright, now if we go over to the week 5 and 6, and I'm gonna run the whole code one more time. Alright, so now let's call our file, which we call this as test.csv. So ts equals to pd.read csv. Our is test.csv. So let's see what kind of data is our. So we have ID, we have subclass. So we have a total of 80 columns, and this is a house data set. So all of these are some numbers related to house itself. They did provide us with the data dictionary, but we're just gonna see the trend of the data. So we're not gonna be doing anything much. All right. Okay. So now, how to identify outliers in this data set, right? Does that make sense? Okay. So let's say Q1 equals to DF. DF is our set. So I'm gonna do it for, what do I want to do it? Okay, I'm gonna do it for the MS subclass. All right, MS subclass. So what is this 25 percentile? What's the Q1? It is at 20. What about Q3? Is at 0.75. This is the core. So 70. So 20 and 70 are the first quartile and the third quartile. Now, this is how you calculate the IQR. Like I talked earlier, IQR is a 70 minus 20, that's 50. Now, our MS subclass, right? So this basically giving me the range of numbers that is below the Q3, Q1 minus IQR, and that's above the Q3 plus 1.5 times IQR. So these are the 104 rows from the one. There's a kind of be considered outliers based on the MS subclass column. Got it? So that's how you find out these things. The next thing is missing values. How are we going to be talking about missing values, right? There is a simple thing to talk about missing values, and it is called df dot is na. That's it. So these are the, it'll say it'll be true if it's missing. So if you see in the alley, it's nan, right? So it's missing, so that's why it's true. So if it's missing, it becomes true. If it's not missing, it's false. And you could also do some things like count. So you can count how many are missing. See, ID 1409 are missing, something like that. You could also say there are a lot of things you can do with it. I'm just gonna leave it at this for now. Next thing that we talked about in this class is handling missing values. So missing values, missing values, missing values, treating missing values, all of these things we're gonna talk about. So first thing is just removing the rows that have missing values. So if let's say this is true, if this is true, we'll just remove the entire row. That's not the best effective way, but if you know that for a fact that that row, if that thing is missing, then you could remove it. For example, let's say you're collecting data about movies, right? And the movie doesn't have a name, you can just remove it. But if you're collecting, let's say, the movie itself, but let's say the genre is missing, you cannot remove that. There might be some mistake in data collection that because of which genre could not be added to the data frame. So in that case, you would not remove the whole row, but you would rather do some other methods. Now, some other methods include forward filling, which is like this. You would just see the first number that occurs, and you would, whatever's missing, you will put the same number on the rest of the. So whatever's in the first is gonna be the same thing for the NaN values. Backward fill, same thing, but what is in the last thing is gonna be on the missing values. So these two you'll be using as per your need. Interpolation is kind of like they are finding the average between those two. So 3 plus 9 is 12 divided by 6, and they'll put in the middle if it's missing. And if the data is sequential, this will be very helpful. Lastly, we have imputation. So let's say we have this row, but one of the data is missing, just one. And all of the value is kind of between 20 and 40. So what I can say is that I can just put 30 in that value. That's called mean imputation. I could find the median of this data and I could put in, I'll call it the median imputation. I would find out the mode of this data, which is how many times a data set, which number occurs the most, and I can just put it over there. I think in this data set, while I was working with it, I did use the median and the mode imputations because it was very messy. Lastly, we have the predictive imputation. Some things like machine learning, logistic regression models, linear regression models. There are models that's just basically studying the data, that's going to study our data, and that's just going to put the value that it thinks it should based on the other data. So it's going to study all the other data as well as that data, and then it's going to predict what should be the missing value. That's what this is. That's what this is. So these are the ways to handle missing data. Now we're going to be talking about duplicate data. So I have written some code by myself over here. Okay, so let me run it. All right. So I created a data set, right? I'm gonna print. Okay. So duplicates equals to df dot duplicated. So this is our data frame, right? Age 15, 26, 26, 48. See, 26, 26, they are repeating. See, 2 and 6 is repeating. Now, df dot drop duplicates will just remove this thing. It will check for every column and it will remove this thing. In contrast, you could just specify columns equals to which over here as a parameter, and you could specify, you can check which columns have the duplicate values. But as you can see, these two things have, I'm just going to print the df first so it's easier for you guys to understand. So as you can see here, the second and the third row, they have the same value. That's why cleaning them is going to just, see, now we only have one value left. They just remove the one of the value. They normally remove the last value because they check the last value is similar to the first value. And then we have this data set. Now, as you can see, the index is kind of messed up. So a fun fact is if you just do dot reset index, it's just gonna reset the index to 0, 1, 2. All right, and it's gonna send out the previous index to here. And you can just remove that using dot remove columns. Okay, we're not going to do that for now because that's not the part of this lecture, because we're just talking about data wrangling. All right, now what else can we do? That was about the duplicate data. Repeated values is kind of the same values repeating over and over again, so we need to figure out why that's happening and properly deal with it as well. Now the fun part, data pre-processing. ChatGPT also uses data pre-processing techniques. Facebook uses data pre-processing techniques. When I do my research at the College of Informatics, I use data pre-processing techniques. Whenever I want to put something in, let's say a model, generative AI model, or even a simple model, or even I want to get an understanding of that data, to analyze that data set, I would have to do the data pre-processing techniques. These are some of the ways to do data processing, but nowadays I think there are more than that as well, but these are the basic ones that we use every time. All right, aggregation. We combine two or more attributes and make it as one. So if you look over here, we might combine the MS subclass and MS subzone, or lot frontage and lot area into one based on the properties that they have. That's it. That's it for aggregation. Sampling is the main thing in data reduction. So what we do is instead of working with the whole data set, we just take out, let's say, 10% of the data and see what's going on, and take out another 10% and see what's going on. And then finally we could implement a solution for everything. That way we could just figure it will be easier because it will not take that much memory. See, time consuming. That's the only thing that's beneficial from it. All right. Dimensionality reduction. All right. So basically what it does is I can just check if this thing and this thing is kind of similar, then I could remove one. But dimensionality reduction is more than that. It's gonna delve in terms of let's just say topics like um, matrix as well as some other techniques, vectors, which is going to be very, very hard for first time understanders. Something like this code. I think I might have the PCA and the K. See, PCA is going to give you the value, and see, it just removed the feature 1 and feature. It just changed the values of feature 1 and 2. So that's kind of what kind of things the PCA does that he talks about here. All right. Now, feature subset selection is process of selecting a relevant subset of features from a larger set to improve model performance. So let's say we want to select some data, kind of similar to the other one, just a little bit different. Make sure you read these slides. Okay. Discretization, one of the very fun concepts, and I think you would be using this quite a lot. I did implement the code here as well. Discretizer, that's the one that will do it for you. sklearn is a library called scikit-learn, which is going to be helping you do all sorts of machine learning stuffs. This is the code. This is the only code that's going to do the discretization. What it did, continuous attribute into an ordinal. So we had 1, 2, 3, 4, 5, 6, 7, 8. It just changed into 0, 0, 0, 0, 1, 1, 1, 1. From a continuous number to a category. That's what this discretizer do. That's it. Binarization. Now this can do more than one, two, more than two attributes. So it can be 0, 1, 2, how many it wants. Binary, what does that remind you of? Zeros and ones, right? So categorical or continuous attributes into one or more binary variables. So it's either 0 or 1. 0, 1. Attribute transformation, of course, we could use some mathematical models to transform our attributes. We could divide everything by, if we have this data set over here, we could divide everything by 10 to get a better number. And then we could say that we did that, right? It's not going to affect our data set that much. Now, that's what scaling is. We use the log scale, log transfer data a lot. I did use a log transfer scaling in this one as well for my, I think it was the sales type. I don't remember much. It has been a long time since I worked with the data. But yeah, I did use log-based transformation. If you have an understanding of maths, then it's pretty good. But what it basically does is log transformed versus non-log transformed data. I'm sorry for the typing. I'm using a new keyboard. I don't have my hands used it. So this is the one that's non-transfer. It kind of looks like skew to the right, right? It has a lot of value. Log transfer, it's kind of normal. That's what it does. It just normalizes the data. All right. That's why you need to use this. And it will also get rid of some of the outliers and stuff. That's why we have to scale it. All right. Some of the examples that the professor gave here. Make sure you read these stuffs. Normalized data model. Okay, how to scale using Python. This is how you do it. All right. Okay, and he did talk about the whole price data set in class, which is very important as well. Now, about pandas, since I was gonna talk in the previous video that I was gonna talk more about pandas as well. What does the apply function do in pandas? One of the most important things that is using the apply function. All right. So if we delve, okay, give me 1 second. I'm just gonna use ChatGPT to ask me generate a code about apply function because it'll be easier for me. It'll save some time as well. All right, I'm just gonna print test this. So this is just me. I like to do that to keep track of what I'm doing. So let's say we have our data and we call our df in the data. So we have this data sets. Now I have a square function that's gonna return the square of a number. All right. Now what I do is I'm just gonna write it apply here. See, a and b got applied to be the square of the numbers. That's it. Simple as that. Every number gets applied to the function. So this gets squared, this gets squared because we passed ab. That's what it does. All right, that's what the apply function is. prediction using apply, make sure you were, if you were in class, you did see that we did some prediction using the apply function. Some data set were missing, we kind of predicted that. Grouping. What do you think grouping is? The group by method, basically, okay, so we have a data set about our United States, various states. So what the group by will do is just get this data set and then combine it by states. Let's say we had a COVID-19 data set and there were, for each state, there were, let's say, 100 million rows. Now, the group by will just call it and it will kind of just give me the average value or the median or the count, whatever you specify. Let's have a look. Okay, so I have a new data set called department employee, and I'm just gonna group them by the department. So I group them by the department, and then I find the mean of the salary. If I do this for finance, the mean is $95,000 or whatever this is. For HR, it's 71. So it's kind of finding the average of the mean of everything. What if I do median here? Kind of the same. What if I do mode here? I cannot do mode, but I think I could do the count thing, right? Yeah, see how many finance, just one, how many HRs, two. So these things, how you learn it, even I don't remember most of them. I go back to this. I think this is one of the most visited sites that I've ever visited so far. Yeah, important things to remember. All right, next. Grouping and collection, that's what we did just now. Reviewing grouping, make sure you, the group by method, that's how you grouping in Python. Pivot. Have you ever used Microsoft Excel before? I think we did do a section in class. I have to make a video about that as well. But basically there's a whole section somewhere over here that says pivot. I don't know where it is, but I think, let's just search pivot. See, pivot table. You could basically make a table. So I'm just gonna put 1, 3, 4, 5, and then let's just create the same data, create the same data, create the same data. I'm so sorry for this. I didn't prepare earlier because I didn't think we're gonna be doing that. Okay, anyways, pivot table. I'm just gonna do this range. I'm just gonna do okay, okay, okay. Anyways, it will not work. So let's just forget it for now. I'll just do it in. We're just gonna do it in Jupyter Notebook then. Alright. So grouping and pivoting are two little bit different things. Grouping would group you based on a specific category. What pivot does is it will have a column, a row, and a value, which you will see right now. All right. Okay. Let's go over here. I'm just gonna do print. All right. So, what do you think the first thing should be? We have to have a data set. So let me create a data set, and then this would be the code. So same thing, employee, department, year, and performance. But performance is something that your, let's say, your manager gave it to you. All right. Like you did over here, you did df.group by, you just do df.pivot. Same thing as that. Alright, let's first see what we get. Oh, so it grouped based on year as well as employee. And every unique values is in the rows. That's what it says. Columns is year, values is performance, index is employees. These are the three things that you need. If you have these three things, you could basically calculate anything from a pivot table, but it has to be only on only three things. That's it about the pivot tables. Make sure you read these slides. All right, now joins. Oh, fun things. If you are going to be taking our computer science or data science major, DSC 200 is a class where you learn how to do those kind of joins. computer systems, I'm sorry, computer database programming is a class in computer science where you'll be learning to do these joins as well. Very important things, but basically there are different types of joins. You could join is just combining two different data frames. So this data frame and this data frame, how can I combine them? They have a same name, right? Location. So I, based on location, I could combine them, and the strata would have a 25% coupon added to this thing. So we'll be basically combining two different data frames. All right. We'll do one example and then we'll end this lecture. Okay, so joining two data frames. Oh, I'm sorry, you didn't see it. Okay, so now we'll be doing joining two data frames. Looks good. Alrighty. So let's see. The thing that we want to remember is the merge function is going to be used in this. So let's say our first data frame is this df1, something like this. And our second data frame is something like this. So employee ID, employee name, department over here, and employee ID, salary, and experience. As you see, the employee ID is the primary key, which is occurring for same amount of times in these sections. All right. Now, the first thing that we can do is inner join. How equals to inner. The code is the same thing, but how is inner? See what we get? We only get the values that is in both of the columns. So 101, 102, 104, and 105 is in this one. 101, 102, 103, and 102. So it only 101, 102, and 104 are occurring in the three values. That's why this is printing this. So inner join will just print out all the rows that is in both of them. What about left join? How equals to left? So our first one is df1, the second one is df2. df1 had 101, 102, 103, 104. So it print 101, 102, 103, 104, 101, 102, 103, 104. So it's gonna print everything on the left data frame. It's gonna print everything on the all rows from df1, but from df2 it's just gonna print out the ones that is matching to df1. If you do right instead, it's gonna print all the rows from df2 for the, but for the ones with df1 it's gonna print none. That's it, the difference between these two. Lastly, there is also called an outer join, which is, I think, basically it will get everything. That's it. Those are the types of merging that we need. All right. So make sure you go through these slides. It's going to be very helpful because you don't want to be looking back into this kind of stuff. Getting good ideas so that it'll be good for your future classes. And if you have any questions, as always, please let me know. All right. Thank you and have a good day. Bye.